Can you believe it? There exists a monster in the universe that can devour stars, tear apart planets, and even light, traveling at 300,000 kilometers per second, cannot escape its control. It has no color, no shape, and is invisible to the naked eye, yet it hides at the center of almost all galaxies, controlling the cycle of life and death in the universe. This is the black hole. Some say it is a space-time rift, others say it is a cosmic graveyard. In many people's minds, a black hole is a huge black hole in the universe, like a vacuum cleaner, devouring stars everywhere. This is actually the most common misconception. A black hole is not a hole at all, but a dense celestial body with infinite density and infinitely strong gravity. The stars and the sun that we usually see are luminous and hot spheres, while the reason why a black hole is black is because its gravity is so strong that light is locked in place once it gets close, unable to be reflected or escaped. Without light, we naturally cannot see it, and it becomes the most extreme dark abyss in the universe. So how did scientists discover black holes, which are invisible and intangible? This is similar to how we can't see the wind, but can see leaves being blown. Black holes, though invisible, have a powerful gravitational pull that affects everything around them. If a black hole is hidden next to a star, the star will be pulled and danced by the black hole's gravity. Interstellar gas approaching a black hole will be torn into pieces, spinning at high speeds and generating temperatures of hundreds of millions of degrees, emitting dazzling light and forming the black hole's halo, the accretion disk. Astronomers have gradually pinpointed the location of black holes by capturing these signals, turning theoretical speculation into concrete evidence. To truly understand black holes, you must first understand two core concepts, which are key to understanding them: the event world and the starting point. Let's start with the event world. It also has a terrifying name, the point of no return. Many people think the event world is the outer shell of a black hole, but they are completely wrong. It is not a solid, not a surface, but an invisible boundary of space-time. To put it simply, if you stand on the edge of a cliff, taking a step back will make you safe, but taking a step forward will cause you to fall off the cliff and never come back. Pause. The event world is the edge of the black hole's cliff. Outside the boundary, you still have a chance to escape the black hole's gravity by speed, but once you cross this line, even in the fastest spaceship in the universe, light could never escape. All matter and information can only flow inwards, never to the outside. The size of this boundary has a specific term, the Schwarzschild radius. It was calculated by physicist Schwarzschild in 1916 from Einstein's theory of general relativity. Simply put, any object compressed within the corresponding Schwarzschild radius will become a black hole. Earth's Schwarzschild radius is only 9 millimeters, about the size of a glass marble. The Sun's Schwarzschild radius is only 3 kilometers. Imagine compressing the Earth, weighing 60 trillion tons, into the size of a marble. How terrifying would that density be? This is the essence of a black hole: constant mass, infinitely shrinking volume. Gravity directly breaks through the limits of the universe, crossing the world and arriving at the most mysterious and mind-blowing core of the black hole. All matter swallowed by a black hole will eventually be infinitely compressed and gathered at a point with infinitely small volume, infinitely high density, and infinitely high space-time curvature. This is the starting point. At the starting point, all known physical laws and scientific common sense become invalid. Time. Meaningful space has no boundaries. We don't know what lies hidden at the beginning. Is it the beginning of the universe, the end of space-time, or the entrance to another universe? This is the greatest unsolved mystery left to mankind by black holes, and also the most ultimate mystery of the universe. Having discussed the structure of black holes, let's talk about how black holes actually come about. The answer lies in the death of stars. Not all stars can become black holes. Our Sun doesn't qualify. In its later years, the Sun will only become a white dwarf and quietly spend the rest of its life. Only massive stars, with a mass more than 20 times that of the Sun, will become black holes at the end of their lives. The life of a star is a protracted battle between gravity and nuclear fusion. Hydrogen inside the star constantly fuses, generating an outward thrust to counteract the inward gravity. Only when the two are balanced can the star stably emit light and heat. But the fuel will eventually run out. When a massive star has exhausted all its fuel, such as hydrogen, helium, carbon, and oxygen, and fuses to iron, disaster strikes. Iron fusion not only does not produce energy but also absorbs energy. The outward thrust disappears instantly, and gravity completely takes control. What follows is the most shocking core collapse in the universe. A supernova explosion occurs when the outer layers of a star are propelled at tens of thousands of kilometers per second into its core. The core is instantly compressed, its density exceeding physical limits, and space-time is utterly distorted, giving birth to a completely new black hole. This is not an ordinary explosion, but the ultimate rebirth of a star. The brightness of the explosion can instantly surpass that of an entire galaxy, brighter than billions of suns. Black holes formed from the death of stars are called stellar mass black holes, with masses ranging from 3 to 100 times that of the Sun. They are considered small in the black hole family. Besides these, the black hole family also includes two giants, intermediate mass black holes and supermassive black holes. Like middle-aged people in a black hole family, a transitional form formed after the merger of smaller black holes. Supermassive black holes, on the other hand, are the true rulers of the universe. Their masses range from a few million times that of the Sun to tens of billions of times. Almost every galaxy harbors such a behemoth at its center. At the center of our Milky Way galaxy is a supermassive black hole called Sagittarius A*, with a mass 4.3 million times that of the Sun and a distance of 26,000 light-years away. And the largest known black hole in the universe, TON 618, has a mass 66 billion times that of the Sun. Its event world could easily contain the entire solar system. These supermassive black holes grow into behemoths by constantly devouring the gas of surrounding stars and merging with other black holes. They are like the heart of galaxies, controlling their birth, growth, and death. Now, let's answer everyone's most curious question: what would happen if a human fell into a black hole? The answer is beyond imagination. In science fiction movies, falling into a black hole allows you to travel through time and see the future, but in reality, it's extremely cruel. You would be turned into spaghetti. This is not a joke, it's the tidal force of the black hole at work. The closer you are to the black hole, the stronger its gravity becomes. If you fall into a black hole foot first, your feet are closer to the starting point, experiencing gravitational pull hundreds of millions of times stronger than your head. This immense difference in gravitational force would infinitely stretch and thin your body from head to toe, turning it into a thin noodle, eventually tearing it into its most basic particles and causing it to fall back to the starting point. Even more astonishing is the time-warping effect of black holes. According to Einstein's theory of relativity, the stronger the gravity, the slower time passes. At the edge of a black hole, time is infinitely slowed down. For you, falling into a black hole, time seems to stand still, while for observers on Earth, you would be forever frozen at the edge of the world, slowly turning red and darkening, eventually disappearing into the darkness. Here in a black hole, time is no longer a uniformly flowing river, but rather is the spacetime frozen in amber by force. Scientists once believed that black holes were cosmic tombs where matter swallowed never reappeared. This understanding was completely overturned by Stephen Hawking's work. In 1974, Hawking proposed the Hawking radiation theory, which shocked the scientific community. Black holes are not eternal, they slowly evaporate and eventually disappear into the universe. This theory sounds contradictory, even light cannot escape, so how could a black hole evaporate? Hawking explained it all using quantum mechanics. The cosmic vacuum is not empty, virtual particles are constantly being created. A particle and an antiparticle are created and annihilated in an instant. However, at the edge of the black hole event world, virtual particle pairs are separated by gravity. One particle falls into a black hole, while another escapes with energy. These escaping particles take away the black hole's mass and energy. Over time, the black hole shrinks and its temperature rises, eventually evaporating completely in a violent explosion. However, there's no need to fear, stellar mass black holes evaporate extremely slowly. Complete evaporation would take 10 to the power of 67 years, hundreds of billions of times longer than the current age of the universe. On a human timescale, black holes are practically eternal. On April 10, 2019, humanity achieved a milestone in black hole research. The first image of a black hole was revealed. To capture this image, scientists worldwide collaborated to use 8 radio telescopes on Earth. A series of telescopes, linked together to form a virtual telescope the size of Earth, took over a decade to finally capture an image of the black hole at the center of the M87 galaxy, 55 million light-years away. The image shows a dark shadow in the center, the black hole's actual world, surrounded by a bright halo, the disk formed by the black hole devouring gas. This blurry image not only confirmed the correctness of Einstein's theory of general relativity but also allowed humanity to see this ultimate cosmic behemoth for the first time. In 2022, the image of the Sagittarius A * black hole at the center of the Milky Way was also officially released. The mystery of black holes is being gradually unveiled. Many people ask, are black holes wormholes? Can they travel through time? Is it real? Here, we must clarify a science fiction misconception. Wormholes are theoretical tunnels connecting 2 points in spacetime, one end a black hole and the other a white hole. Black holes devour matter, while white holes eject matter. Passing through a wormhole could traverse billions of light years. However, this is merely theoretical speculation. Humans have yet to find any evidence of wormholes' existence. Moreover, wormholes are extremely unstable, even a tiny amount of matter entering them would cause them to collapse instantly. To stabilize a wormhole, humans would need negative mass matter, which has never been discovered before. White holes, on the other hand, are the complete opposite of black holes. They only expel matter, constantly ejecting it outwards. Currently, they only exist in theory, with no observational evidence. Therefore, a black hole is not a space-time tunnel, nor is it an entrance to another world. It is simply a celestial body governed by extreme physical laws. The plots in science fiction movies, don't take them seriously. Finally, let's talk about the most realistic question: will black holes threaten Earth? The answer is absolutely not. Many people worry that black holes will devour the solar system, but this is completely unfounded. The closest black hole to Earth is 1,600 light-years away, and its gravity has no effect on the solar system. The supermassive black hole at the center of the Milky Way is 26,000 light-years away, and the solar system revolves around it smoothly, just like Earth revolves around the Sun. It's safe. Black holes are not cosmic madmen that wander around aimlessly. Their gravitational range is limited. Only when matter actively enters their event world will it be swallowed up. In the vast universe, black holes are like a quiet observer silently guarding the galaxy's movement, never actively harming Earth. Black holes are the most mysterious existence in the universe, the ultimate limit of spacetime, and a gemstone of human intelligence. From Einstein's theoretical predictions to Schwarzschild's mathematical calculations, from Hawking's radiation theory to real-world images of black holes, humanity has spent over 100 years gradually approaching this cosmic behemoth, unraveling its mysteries. It makes us understand that the universe is far more vast, more wondrous, and more mind-blowing than we imagined. Humanity is as insignificant as dust before the universe, yet we can use our intelligence to gaze at the stars, explore black holes, and understand the language of the universe. Whispers, this is the charm of science, and also the romance of the universe.